Hi everyone, welcome to dot point A13, and today we're looking at outlining the role of objective measurement and heritability on the breeding program of farms using at least one specific industry program as an example. So first of all, we need to look at what it means to, or what objective measurement means. So the other type of measurement would be subjective measurement, and subjective measurement is one that's based on opinion, and it's subjective. Obviously, it means it is qualitative rather than quantitative. However, objective measurement is something that can be measured. So something that can be measured using a scale, and you can't argue with it really. It's not subjective. So we have subjective and objective, and the one that we're looking at is objective. It means something that can be measured. So we're looking at the role of objective measurement on scale and heritability on breeding programs. So heritability basically means the chance of some trait being passed on. So when we're in breeding programs, we like to choose traits that are easy to pass on, and a lot of the traits that we talk about all the time, like milking volume, muscle score, calving ease, various other traits like that we talk about regularly, they are highly heritable. The chances of them being passed on are high, and the chance of the offspring showing those traits is high, which is why they're called highly heritable. If they were not highly heritable, or say lowly heritable, then you wouldn't really focus on breeding those animals or those traits because it would be very hard to get them to pass on. So we're looking at how we can objectively measure traits on a scale that we can compare animals against, and also passing on traits that are easy to pass on, basically, and easy to get the offspring showing those traits. And we need to use at least one specific industry program as an example. So that is going to be Breedplan, a system called Breedplan, which was developed in Australia. And we'll also be using EBVs, or estimated breeding values, which are what is used as part of Breedplan. But we'll get onto that in a second. So first of all, we need to look at objective measurement and heritability in a bit more detail. So what we're going to look at is how farmers can measure the traits of their animals and methods they use to evaluate which traits are more prominent or more heritable in one animal over another. And this allows farmers to choose animals with particular traits that they wish to incorporate into their herd or flock via breeding. So these methods allow numbers to be associated with traits. So for example, measurement of birth weight, fat depth, etc., which can tell a producer the breeding value of an animal that they have not seen compared to others that they may or may not have seen. So basically, we want a system, and the system we're going to look at is one like this. We want a system where every cow, say in Australia, that's an Angus cow, can be measured and put on a scale, and you can then see, how different cows compare to each other in terms of their birth weight, in terms of their milking volume, and various other things like that. Okay, so as I said before, subjective and objective, basically the difference here is subjective is based on opinion. So an example, a kind of unrelated to agriculture example, if you were talking about, going out to dinner or going to a restaurant, and you ask someone, was your dinner good? You're going to get a subjective response. Some people are going to like it. Some people are not going to like it. They might have had the same thing, but whether they like it or not is opinion-based, and that's what we call subjective. On the other hand, something that is objective, and a question you could ask that would be objective, would be something that's measurable. So for example, you could ask someone the same meal or the same time and they went to the restaurant, how many grams was your steak? And obviously that's going to be something that if they know what the answer is, then they can compare it, and you know what it means. It's not subjective, it's based on a scale, and obviously they'll say, it was 250 grams, 300 grams, and when they tell you that, you know exactly how it is, how much that is. And so that is what we see as objective. It's not opinion based, it's based on some kind of scale, some kind of measurement. Moving on, this next question, in your opinion, outline why objective measurement in traits might be beneficial. Basically because you can easily compare animals to each other on different farms in different states. So I might have an Angus stud farm in New South Wales, and I want to improve the milking volume of my cows, and maybe I can look at numbers of milking volume of Angus cattle in somewhere else. I can just look it up online, or I can get the information somehow without seeing the cattle. And if they have a measurement, an objective measurement on a scale, then I will know how exactly how much they are likely to produce. So then I would be able to tell whether they are worth breeding with, even if they're not in the state, or they're on a different farm that you can't see them. So that would tell you whether it would be worth using things like artificial insemination, embryo transfer, and buying in the genetics from interstate or overseas. These pictures that I put here to make you, to remind you that when we talk about Breedplan here, Breedplan is basically a system of improving the traits in your cattle by evaluating the genetics of cows. And each different breed has its own breed plan. So at the moment, there's no universal breed plan across all cattle. So each individual breed, such as Angus, Murray Grey, Santa Gertrudis, Simmental, and Brahman, etc., all have their own breed plans. So when we look at EBVs shortly, the EBVs are all different for different breeds. But within a breed, if you have Angus cattle, you could check against any other Angus cattle in Australia, their EBVs, and they would all be on the same scale. But each breed has its own scale or measurement system, basically. Or a better way of putting it would be each breed has its own kind of zero level, or baseline where it was set at originally. All right, so moving on to what heritability means, because that was the second point of the dot point. We looked at objective measurement and heritability in a breeding program. So heritability basically refers to the amount or the likelihood of a trait being passed on and displayed in offspring, and the degree to which this occurs. So for example, if one cow has a 10 litre high milking volume above average, and all of its offspring get all of this 10 litre increase, it's said to be a highly heritable trait. Some traits are highly heritable and some traits are less heritable. Some traits just don't get passed on. They kind of show up randomly in some cattle and just don't get passed on to their offspring easily. And those traits are said to be lowly heritable. And so basically, this next question, outline why you would want to measure and breed animals off highly heritable traits rather than lowly heritable traits. And the reason is because highly heritable traits are likely to be passed on and displayed by offspring. And so that makes them easy to select for, and it's less time consuming, and subsequent generations will actually show that trait if they're highly heritable, whereas trying to pass down lowly heritable traits is very hard. All right, moving on to what we call the industry program. So basically the industry program is Breedplan, and Breedplan uses EBVs. All right, so that's important to know. The industry program that we're talking about for genetic evaluation and breeding is called Breedplan, and EBVs are used as part of Breedplan. So let's have a look at what Breedplan and what EBVs are. So firstly, what is Breedplan? If you went to the Breedplan website, you would have looked up this information, but Breedplan is basically, this is straight from their website, it's a modern genetic evaluation system. So it's evaluating the genes of an animal, and it uses EBVs, and they are called estimated breeding values. So they're what we estimate will certain traits, how good certain traits will be in animals. And it's a system that uses EBVs of recorded cattle for a range of traits that are important to producers. Example, milking volume, weight, fertility. And we'll look at these traits a bit more shortly. And so each breed, as I mentioned before with this this bit here, each breed has its own breed plan and EBVs due to differences in breed. So you can imagine that, say, Hereford compared to Angus will have different kind of milking volumes on average. And so the EBVs are slightly different. So that's why each breed has its own breed plan. The next point is, what is an EBV? So an estimated breeding value, which is used as part of a breed plan, which is a genetic evaluation tool. A breeding value is a genetic merit for a trait. So we cannot know exactly what this value is, because we're just kind of measuring what we see. And so we can estimate it. And basically they're expressed as the difference between an animal's genetics and the breed's genetic base. And so what you get with EBVs is you get a number that is like +10, -5, or anything on the spectrum. It could be 0, it could be 1, it could be -1, it could be -25 or +25 or anything else. And so the important thing here is it says EBVs are expressed as the difference between an individual's genetics and the genetic base to which the animal is compared. The genetic base can roughly be described as the historical genetic level of that particular breed. For most breeds, their genetic base will have been set in the mid-90s. Importantly, the genetic base for each breed will be different, so EBVs for animals within a particular analysis can be directly compared. Therefore, in the above example, a 600-day weight EBV of 41 kilos means the animal is 41 kilos heavier genetically at 600 days compared with the genetic base of the relevant cattle population. So the important thing here is that it said the genetic base will have been set in the mid-1990s. So if we're talking about Hereford, for example, let's say milking volume, we'll use milking volume and Herefords as our example. And in the 1990s, when they set up the Breedplan and the EBVs for Hereford, what they would have done is taken an average of the milking volume for Hereford. And let's just say, for example, that was 25 litres of milk that each Hereford cow would produce on average. So what they did in the mid-1990s is they set that the 0 point or the base. So they said that 25 litres is now 0. Okay, so a cow that produces 25 litres is considered 0. Their EBV for milking volume will be 0. Anything above that, so let's say a cow produces 30, which is 5 above, they will be +5. Let's say a cow produces 35 litres a day, they will be +10 because they're 10 above 25. Or on the other side, if a cow produces 20 instead of the average of 25, they're -5. If they produce 15 litres a day, they're -10, etc. So we now have a number which is plus or minus the average or the baseline that was set in the mid-1990s. And so we can see whether the traits are improving or going backwards. And depending on what the trait is, most traits you generally want a positive EBV. There are some traits which we'll look at shortly which you actually want a negative EBV. Alright, so from the above text box, basically, why is it not possible to compare EBVs across breeds? And like I said, different breeds have different genetic bases. They're better or worse at particular traits. So, Angus are better at marbling. Hereford are better at mothering ability. So they have different traits. And basically, the baseline is different for each breed. So they can't be compared to each other. However, there is work underway to make a universal EBV system, but it can't be done yet. So hopefully one day in the future we'll have a universal system where all cows can be compared and all cattle can be compared on the same scale. All right, the next section is looking at basically all of the traits that we have EBVs for at the moment. Now, the reason this bit is important is not because you're going to have to write all of these out in an exam. However, it has come up in past papers where in multiple choice they may put out a handful of EBVs and throw in some fake EBVs, ones that aren't actually EBVs, and ask you to choose which ones are correct EBVs. So that's why you need to kind of look at this and know whether an EBV may or may not be a real one. So for example, we have birth weight, milking volume, 200, 400, 600 day weight. We have mature cow weight, so it doesn't go above 600. There's no 800 day weight. There's no 1,000 day weight. Most cattle are not alive by that stage if they're being used for beef production. So it's not a trait that's very, very important, and producers don't want to know that as much as these other ones. So there's nothing above 600 day weight. And in past papers, past exams, they have thrown in fake EBVs like 1,000 day weight, other things like rumen volume, which are not really relevant at all and not easy to measure. So they are not EBVs, but these ones here are. These ones also are all here, and scrotal size is important. So scrotal size we'll talk about shortly, but that is an example of the larger scrotal size a bull has, the more fertile it is, and the more fertile its offspring will be. So that is important, and it is measured. Days to calving is another one which we'll talk about shortly, but basically days to calving means if a cow, between when it was placed with a male animal and when it gives birth, the shorter that amount of days are between those two things, the more fertile the animal is. And so days to calving is actually one of the few EBVs where you definitely want a negative. The higher the negative, the better or more fertile the animal is. Gestation length, or the length of the pregnancy, can be measured. Calving ease can be measured. Eye muscle area, fat depth, retail beef yield or carcass amount, intramuscular fat or marbling, carcass weight, shear force. You can look these up on this document and it'll tell you what each of these mean. But shear force is like the strength of the bones basically, and telling you about how good their bones are. Docility just basically means how placid or how calm it is, or how agitated it can get, and that can be measured. Net feed intake, structural soundness, and flight time. So you probably know about fight or flight, and it's kind of, again, that's behavior related, and how able it, or how much it is, it gets upset easily. Moving on to these ones, just a few questions here. So looking at visual appraisal, outline why you would include visual assessments as well as using EBVs. There's many other traits that you need in a cow, and not just the ones that are listed as EBVs. So someone who would buy animals based off their EBVs would often want to see the animals as well. And it's probably good at this point to look at this example in practice. This is an example of Ross Thompson's farm, who we went to visit twice in year 11 and year 12. And this is an example of his bull sale brochure, which you may have looked at in class, but this is from 2016, and this is an example of his brochure here. And basically, if you scroll down, you'll see that all the cattle that he was selling on that day were listed here, and you'll see photos of them. And so obviously getting a good visual assessment of the animal's kind of structure, its bone structure, its body shape, is helpful as well. So it's good to have a visual assessment of the cow as well. But you'll notice here that all the EBVs are listed as well. So basically, we have all of these EBVs for the animals. So you can see milk volume plus 16, scrotal size plus 2.9, etc. There's a whole pile of them there. And if we have a look down here, you can see we can compare them to each other. So the milk volume of this one is plus 15. The milk one is this one's plus 16. The scrotal size here is plus 1.9. The scrotal size here is plus 2.9. So this one might be a better male to have, and it might be more fertile because it has a larger scrotal size on average than this one down here. Whereas if we have a look down here, we can scroll ahead and look at scrotal size. This one has an even larger one, plus 3.2. Milking volume here is plus 19, plus 18. So there's some good milking volumes here. And so depending on what trait the producer wants to improve, so when people go to the auction at Millamurra and they want to buy Angus cattle to breed into their herd, they would choose different traits that they want, and they might say, okay, I really have to improve milking volume in my herd this year, and so they might scroll through here and kind of find the one with the best milking volume, and it looks like, oh, here's a good one here, plus 21, plus 20. So you can see that they would scroll through here and look for the ones that they're most interested in based on their milking volume. So going back to this, this is an example of why you'd want to use visual assessment, because not all traits are EBV traits. There's other things that aren't measured that you would want in a cow. And structural soundness and temperament can be measured a little bit, can be measured in EBVs, but you also want to confirm that by visual assessment. The next one is on birth weight, and it says, why is it favourable to choose animals with smaller EBVs for birth weight? Basically, the reason is if you have a cow giving birth to a really, really large calf, it's probably going to have birthing difficulties, and what we call that is dystocia, spelt here, and that means that they have trouble giving birth, and obviously that can lead to the animal or the calf potentially dying. So if the EBV for birth weight is quite high, it means that there's a good chance that there'll be quite a large calf because it's going to be quite heavy. So generally speaking, you want the birth weight EBV to be kind of lower, not too large, because it will lead to probable birthing difficulties. The next one on growth, this is just some general questions. What type of farmer would find a 600-day weight EBV most useful? So 600-day weight is like 2 years old roughly, and by that stage the animals are pretty heavy, they're heavy steers, and they're going to be putting on a lot of fat by that stage and finishing in a feedlot most likely. So that's someone producing heavy steers would want to look at the 600-day weight EBV. But remember, it doesn't go past 600, that's the highest growth rate EBV, or weight EBV. The next one, as I've already mentioned a bit, Why scrotal size is important. Why is it useful? Because as I mentioned, increased scrotal circumference is linked to increased semen production and earlier age of puberty in bulls and heifer offspring. So if a bull has offspring with a cow, both the males and the females will hit puberty earlier if their father has a larger scrotal circumference. So that's an important fertility trait, and a large increase will improve these traits and improve fertility. So generally speaking, an increased scrotal size is important. All right, the next one here is there's two pages of exercises on actually picking out these things. And it's important to note when you're choosing these that there's best answers, but there's no absolutely correct answer, because generally speaking, this is the preference of a farmer. So what I've chosen here is I've picked out two categories that each buyer wants. So they want vealers and they want to increase milk production. So then I've looked at two columns and I've kind of chosen between the two of them. But remember, different farmers are going to have different preferences. So if they had to choose between ones that were very close to each other, they might choose the 400-day weight one over the milk volume. They'll decide based on their own preferences of what is more important to them. So these are basically, some are more right than others, and there's not always one correct answer necessarily. But let's have a look at these. So buyer one here sells vealers, and vealers, remember, are kind of under a year old calves, and they are going to be sold somewhere between 200 and 400 day weight. So somewhere in the middle here, because obviously a year is 365 days. So they're going to be sold somewhere here in the middle. So they're going to sell vealers, and I'm guessing they want them to be pretty heavy. So you want a high plus value above the breed average, and increasing the level of milk production. So we have our milk production here, and so we want to have a high plus value because we want to increase the level of milk production to improve profitability. So we're just going to focus on the 200, 400 day weight and the milk volume. So let's have a look here first at the highest 200 day weight, and it's 16 and then 14. The highest 400 day weight is plus 40 and plus 35. Okay, so and then there's plus 25 here. So we're looking at that, and then milk volume is plus 5, plus 2, plus 10. Okay, so that one has the best milking volume. That one's reasonable. That one's pretty low. That one's negative. It's going to have a lower milk volume than the breed average. So we can rule that one out because C, it's not going to have milk volume, which they do want. So we can rule C out. So it's basically now between A and D. With A, we get plus 5 milk and plus 30 weight. And down here with D, we get plus 10 milk and plus 25. Now, you could potentially choose A or D. But if we have a look at 200 day weight here, we've got A 10 and D 10. So you could potentially choose A or D. But D is going to give you more milk volume. So I've put D here, but if you put A, that's probably just as legitimate. It depends on the farmer. The farmer's going to make the decision based on what's more important to them. So A or D here is okay. Buyer 2, they want to increase yielding and final weights and avoid calving difficulty, and the main product is heavy steers. And so heavy steers are going to be kind of 600 day weight, or 2 years and above. So let's have a look at calving difficulty and heavy steers for this farmer. So calving difficulty is going to happen when you have a high plus value of the birth weight. So we want to avoid a high plus value to avoid calving difficulty. And we want to have a high 600 day weight. Okay, so our highest two here are 50 and 45, and our birth weight -1 and plus 5. So if we're going to choose between these two, there might be birthing difficulties here with a plus 5 because it's quite a large calf. So -1 is basically saying there really isn't going to be any problems with birthing difficulty. So with our 600 day weight here and plus 45, that's still good. Plus 50, it's not as much, but the birth weight is better. So the chances of having birthing difficulties is much lower. So I'm going to go with A there. So I said probably bull A. Basically this one here, straight breeding in a harsh environment where cows with high EBVs for milk are slower to rebreed. So you probably want to have cows with a lower EBV for milk because that will mean they will rebreed quicker, which is what this is suggesting here. Large mature cow size is also not favoured, and they want increased growth rate in 2-year-old steers. So here we have 2-year-old steers are going to be 600 day weight. Large mature cow weight not favoured, so mature cow weight, they don't want it to be too big, but they do want a big steer size here. or a big growth rate here with the steers. And the last one was EBVs for milk. They want it to be quite low. So if we have a look here, again, we've got, if we have a look at our top ones, plus 45, plus 50, plus 40. These are our top 600-day weights, so we could use any of those. What can we rule out first? This one here has got a large mature cow weight. It's the largest. So that's probably out because it says large mature cow size is not favored. Then we look here. So we've got plus 50, plus 45, plus 52 is quite a large mature cow rate. But down here you've got plus 40 and plus 36. So basically now it's between, so it has a high 2-year steer weight, but it has quite a low mature cow weight, which is what they're after, a large mature cow not favored, increased growth rate in 2-year-old steer. The last one here is high EBV. So how do we decide between, say, these two? Well, this one has a lower mature cow weight. This one has 0 milk. So there's no increase in milk volume, which is good because it will rebreed quicker. Whereas this one up here has a plus 5 for milk. So that basically says that we really need to choose E there. It's clearly E in that case. So I said probably bull E. This one here, we want to choose probably 600-day weight for 2-year-old steers and improve female fertility. So remember, I mentioned before that DC here, which means days to calving, the lower that is between the time that the male is put with the female and the cow giving birth, the less number of days means the cow is more fertile. It got pregnant quicker and it gave birth quicker. So therefore, a lower days to calving, a higher negative here, or a more negative number, is better. And there's few EBVs that are like that, but not many. So days to calving, we want it to be quite negative. Heavy steer weights, so we've got 600-day and 2-year, as it says here, 600-day weight. So we need to compare this and this. So we want a highest of possible of this while having a low DC. So we've got two here, with the two highest here are plus 58 and plus 50, and we go across and look at those, and we've got plus 12 and minus 9. And so like we said, we want plus 12 is quite significant, so that's probably decreased fertility, and this is increased fertility. So a bit of a trade-off here on the 600-day weight, but there's a significant improvement in fertility. So we have plus 50 and minus 9. So I'd say that one is going to be A. The next one is heifers and steers and yearlings. So we're kind of going to go 400-day weight, which is the only one showing here. There's no 200-day weight. And steers, which is our 600-day weight here. So let's have a look at the highest ones. We've got plus 58 and plus 50. We've got plus 48 and plus 40. So the highest one for 400 and 600-day weight is clearly D. That one's an easy one. Buyer 3 wants to increase scrotal size in this stud herd. Yearling bulls, so that's a clear one, scrotal size here. Yearling bulls are sold in the past. Some have marginal scrotal size. The buyer is predominantly breeding predominantly breeders of yearling steers, which is 400-day weight. So we want to look at scrotal size and we want to look at 400-day weight. So if we have the highest here, the highest scrotal size is plus 2.5. The highest 400-day weight is 48, 44, and 43. So if we go 48, it has a minus 1 scrotal size. So that will not fit here because they want increased scrotal size. Plus 44, which is the next one, is plus 2. That's good. But this one's plus 43 and it's plus 2.5. So for a very small difference in 400-day weight, you have a reasonably big difference in scrotal size, an increase here. So I said that should be probably bull E. It would be the best option there. But if you put B, that may be justifiable, but E seems to be a better choice, but slightly there. All right, here, if we look at this table, these are past HSC questions, this table of estimated breeding values for 4 bulls. We have the bulls and the estimated breeding values for birth weight, 200, 400-day weight, eye muscle area, and rump fat. Now, it says which of the bulls would be most suited to use as a sire, which means a male father, on heifers, meaning females that haven't had calves before, in a herd which supplies steers to a feedlot. So we want to have animals that are putting on a lot of weight for a long time because they're going to be in a feedlot, putting on weight and fat, and they want to have good EBVs for eye muscle area and rump fat. Also, remember, these are heifers, they're first-time mothers, so you want to have kind of calves that are not too large, because that will lead to birthing difficulties, especially for a cow that hasn't had a calf before. So if we have a look here, first of all, we can rule out W straight away because it has a very high plus value for birth weight. So it's going to have a very heavy calf, and that's not good. So we can rule W out straight away. So we're already on to B, C, and D. If we have a look here, all the remaining ones have very clear difference in their 400-day weight. The 200-day weight's similar there, so plus 60, but you can see the 400-day weight is significantly higher, 6 times higher here for Y, and then the eye muscle area is also higher. So this is a really good animal here for feedlotting, because you're going to have it for 400, 600 days in a feedlot, putting on a lot of fat and some muscle as well. So the answer here basically is why this one's a really good animal. It's going to have a -2 birth weight, so there won't be any birthing difficulties, hopefully. It's going to have a good 200-day weight, but a very good 400-day weight and good eye muscle area. So definitely the answer there is why. This next question from 2014, explain, so cause and effect, how objective measurement is used to select breeding stock. In your answer, include a specific example. So straight away that's saying you need to mention EBVs and Breedplan here. And basically also you need to talk about why objective measurement is good, what it is and why it's good. So again, this is a sample answer off the Border Studies website. It's basically showing you the minimum amount that you need to get the marks. I'd always hope that you would put more detail in than this. So objective measurement is used by farmers in order to select breeding stock. Farmers could use objective measurements and give them a value, as in the case of EBVs used in a breed plan. Here values are used to decide what sire or male or dam or female traits are required, and they are bred with the relevant partner. Their offspring's value can be calculated, and thus over time these measurements can be continually used to obtain breeding stock for the trait required, example calving, birth weight, 400-day weight. So you can see that they've given their industry example, the specific example, Breedplan EBVs. They've given the examples of the EBVs, which is absolutely required for this question. Also, what I would like to have seen you do in a better answer would be to just quickly say what objective measurement is. So objective measurement is something that can be measured on a scale and not have any subjectivity about it or opinion enter into it. If we move down here, an animal's production data is often used to decide whether or not to use the animal for breeding. What is the name given to this method of breeding stock? And its objective measurement is what is done there.